Yeah. Yeah. Is my screen is visible? Sir. Thank you, ma'am. So till now, we have discussed concepts like scalars, vectors, matrices, that means matrix, tensors, and also we learned some operations on matrix. So most of the operations are performed on matrix because scalar is a single entity. So single individual value is represented in algebra using scalar. A vector, you know that the definition vector is represented like this. It is a one-dimensional array. In programming, we are using one-dimensional array to represent this. Sometimes we'll use column vector like this, one column with two rows, or else we can create vector like this. This is called row vector. So a row is having a number of columns. So this is column vector, this is row vector. So these two are valid. We are using vectors representation like one dimension only, but it is a row or column. Row vector, this is row vector, this is column vector, like this. And another thing is matrix. We have discussed this in last class. The matrix is represented using arrays only. In a programming point of view, I'm saying. So the matrix is always represented with two-dimensional array. It is represented with two-dimensional array, 2D. It is having rows and columns. Rows and columns. This is 2 by 2 matrix. So we can say it is square matrix. Like that, we are using basic algebra representations in our programming. Now I would like to take an example. How we are applying these things. See this example. So consider student marks in his exam. His marks for 3 subjects is calculated like this: 80%, 80% again, and 85%. So 3 subject marks, 80, 80%, and 85%. So based on the difficulty level of the paper, okay, the faculty is given weightage. 30% weightage for the first subject, 30% weightage for the second subject, and 40% weightage for the third subject regarding to these exams. Now, our intention is we have to calculate, we need to calculate weighted mean. How we are going to calculate this weighted mean? So this is a mean. That means we need to do the average of marks. As usual, mean means is average. So X bar we are calling, but here we are calculating weighted mean. So because it is having weight values along with marks. So weighted mean we are calculating like W bar weight equal to weight 1 plus subject 1. Weight 1 into subject 1 plus weight 2 into subject 2, weight 3 into subject 3, and so on, divided by total number of weights, because we are calculating a mean in terms of weight. So sum of weight. This is a basic equation we are using to calculate weighted mean. In mathematics, we are applying this type of weighted mean calculations, and we'll do all these calculations as per the required solution. Here, my point is how we are representing these subjects, that is X. How we are representing this weight value, that is W. So here, X is represents like a column vector or a row vector. W is also represent like a column vector or a row vector. Okay. So X is having, X is here, it is a subject. Subject is having different percentages like 80%. See here, this is 80%, 80%, 80 and 85. So this is considered and as a vector because it is a vector. Vector is having one dimensional array, simply like this simple array row wise. Okay, and weight values is also considered like 30%, 30%, 40% weight values. So this is weight vector. So by using this type of vectors, we are reading the values and we are performing the calculations. In programming, we need to read values in terms of vector and store into the vector variable. So similarly, weight vector store these values into the weight vector variable. This is the difference. In mathematics, directly we'll take like this and we'll do the calculations like this. But whereas in programming, you need to consider vector. This is symbol, vector symbol, array symbol. Okay, then you have to assign these values into your vector. So like this, we are doing calculations. I'm going to discuss with another example. Say for example, we have a graph like this. We have a graph like this. So graph is, you know the definition, graph is a combination of vertices and edges. Okay. Here this is vertex 1, vertex 2 and so on, vertex 5. And these are all the edges. Edges is represented with arrows. So you can say it is a directed graph. In this directed graph, every edge, okay, sometimes they are giving weight values 10, 5, 3, and so on. Sometimes they are giving weight values. Sometimes they are not giving any weight values like this, empty. They are not given any weight values like this, empty. So how we are doing calculations on this? How we are performing calculations, this type of graph. So here, what is a algebra method like scalar, matrix, vector? Which one is considered, and how we are converting this data, graph data, into the program? Okay, so for this, you know that this is one of the fundamental basic concept in data structures. Okay, so how we are representing this in terms of doing the operations. Operations on graph is performed either using relational matrix. We need to convert this into the relational matrix or linked representation. Matrix representation or linked representation. These two are possible ways. Okay, so we are creating matrix representation, that is relationship between the edges to edges, vertices to vertices, like this. So there is an edge from V1 to V2. That's why we are mentioning 1 here. So like this, we are creating relationship matrix. Okay, so this relationship matrix is used for doing the calculations in programming. Okay, suppose the weights are provided like this. I mentioned 10. So V1 to V2 weight value is 10. That means this weight value is 10. So like that, V1 to V4 is a weight that is 5. So you can mention this 5 here, V1 to V4. Like this, you need to create your matrix. Okay, so based on the graph notation, we are representing the data into a relationship matrix. That matrix is used for doing the calculations. So like this, we are creating a matrix. This is a matrix. Okay. So this is matrix 1 or vector 1, or earlier example, we can consider X. Okay, something. Whatever it is, we are considering the matrix. How we are converting graph into matrix, and this is the way we are converting matrix relation matrix based on the graph. This is nothing new here. It is a basic data structure concept. In data structure, graphs are represented either this, or we are using linked representation. Vector 1, vector 2, vector 1 to vector 2 having a link, vector 2 to vector 5 having a link. This is vector 5. Vector 2 to vector 3, right? This is vector 3. So V2, V3, like this. Okay. Either we can create data in this format, or we can use linked representation to perform the operations. This is basic data structure. Same thing we are using here, but for our calculations, we have a matrix. So matrix is used to store the data. So that's why we are using matrix representation to store these values in terms of matrix. Okay. This is the major usage of scalar, vector, and matrix. So now I think you know very well about this, how important it is. Linear algebra plays a key role in our programming, particularly when we are dealing with deep learning concepts, machine learning concepts. In all the cases, we are storing data in terms of vectors or matrix. So that's why we should know what type of operations we are doing on linear algebra, particularly vectors and matrices. So now I'm moving on to the program part. So as of now, we know how to declare vector, definition of a vector, matrix, how to define matrix, and definition of a matrix. We know what type of operations we are doing on a matrix. So we are doing different operations like matrix addition, matrix multiplication, vector addition, vector multiplication, dot product, transpose of a matrix, transpose of a vector. Okay. Similarly, we learn orthogonal matrix, and also we learn symmetric matrix. All these things we have learned in the last class. Okay, now we'll see how we are going to create programs for these vectors and matrices. This is one simple example. This is written in Python programming. So my intensity is, I would like to create a vector. So this vector is column vector. I would like to create a column vector. This is having 2 rows and 1 column. 1 column because this is column vector. That means I would like to create a vector, column vector. Like this, I would like to create a column vector. This vector is having two rows, like this, 2 rows. In our programming, Python, to declare this, we are using NumPy library. Okay. We are using NumPy library. So using NumPy library, we are doing all our mathematical calculations. Remember, the mathematical calculations are done using NumPy, because NumPy is one of the Python library which is having mathematical functions. More mathematical functions are there. Okay. And also, you know that you are in 3rd year, you know that we are using pandas also. Pandas are used to do the calculations in terms of statistical calculations, visualizations. So MATLAB library is there, like so many libraries available, but here in our programming, we are using NumPy because we are doing mathematical calculations. because linear algebra is one of the mathematical concept. One of the mathematical concept, it is having continuous data elements. So all these things we learn in first class. So now see this, how we are creating vector. So you know that vector is a one-dimensional array, either row-wise or column-wise. So using a array, np.array function. So np.array function, we are creating one-dimensional array because it is a one-dimensional array. Okay, in this example, I'm creating two rows. Okay, how we are how this array is working? So the array is represented with the square brackets in programming. Okay, np.array. See this, np.array np.array we are declaring. So here it is represents with normal brackets. Okay, normal brackets. Inside this we can represent like 1, 2, 3, 4, like this. This is a normal array. So what type of array it is? It is a row array. Okay, so with this, how this array is created? What is the output? Output is like 1, 2. In programming, we are representing with square brackets. In mathematics, we are representing to represent a matrix in square brackets. That is 1, 2, 3, 4. So this is called row-wise matrix. But our intention is we have to create column vector, not like this. Not like this. We have to create column vector like this. It is having values 1, 2, 3, 4 like this. Like this we are going to create, not like this. When you are representing in this format, by default, it creates row-wise matrix. Okay. Suppose if it is having two rows, so how we are going to represent two rows? So one row is represented with one square bracket. Okay. And give the comma. Second row is created with second square bracket and close a normal bracket. So in this second row, you can insert values like 4, 5, 6, 7. So automatically our array will be created like 2 by 2 because two rows, 2 by 4, 2 rows, 4 columns. 4, 5, 6, 7, like this. It is having two rows. How? Because we are represented first row with first square bracket, second row with the second square bracket. Okay, so it is having two square brackets. It represented two different rows, right? So it is forming like this. So this technique we are using. Okay, this technique we are using to create our column vector. Column vector is having only one column. Okay, only one column. That means it is not having second column, third column, fourth column. It is not having this type of columns. So same in second row also it is having only one column. So how we are representing means, see, this is first row, first element. Okay, this is second row, first element. So when we declare like this, okay, I'll make it clear. Now see this. This is the way we are representing. See here, this is one square bracket that represents column. Okay, one that represents column. Inside the column, this is first row, this is second row. So we have one column and first row, second row, like this. You should remember, I think you know very well all these things. Anyway, our first unit in deep learning is a revision of mathematics, revision of Python programming fundamentals. Second unit onwards, second unit is also a kind of a revision of your machine learning. Third unit, somewhere in the middle of the second unit, will start deep learning, actual deep learning concepts. Up to 1.5 unit, it is a kind of revision. If you are good in mathematics, algebra and all, and you can easily understand the concept. If you are good in Python, basic Python, you can easily understand all these things. But what I'm trying to convey here is, I would like to give more clear information with scratch from the basics. That's why I'm explaining very slowly. You need to learn the concepts. If you are missed, if you are not able to understand earlier classes, now you have to know how to define arrays, how to define matrix, how to define vectors in Python. So like this, we have created one vector, column vector, name is called call vector, and I am printing that call vector using print statement. Okay, so this is the way we are creating a matrix. Okay, so we can call it as a matrix because this matrix is having only column matrix. Column matrix is called vector. And this is another example. I will run these programs also. I will run these programs because in your lab session, I think you are having lab hours. In your lab, you need to do all these programs, convert all these programs. Try to note it down these programs in our lab manual, lab observation, and do these lab programs in the lab sessions. So this is another example which is creates again vector. So vector with zero rows, the dimensions are 3 using number. That means I am creating row vector, not a column vector. Okay. Earlier example I have created column vector. Now I am creating row vector. This row vector is having 3 dimensions. That means 3, first, second, and third dimension, 3 dimensions. So all these dimensions occupies 0. Values are 0. How we are creating this means using mathematical library function np.array zeros. This is 0 vector. So 0, 0, 0. When we pass 0, 0, 0, it creates a row vector with 0, 0, 0. Okay. Second one, see this. Row vector with 0 function. We have one more method is called function method. So you need not to mention like this. You need not to mention 0, 0, 0. Suppose if it is having 10 values, 10 zeros, you need not to write 10 zeros. We have a function in Python, np.0 function. So by using this function, you can create a vector. Okay, you can create a row vector with n number of dimensions. All the dimensional values are replaced with the zeros. Okay, we have a function np.zeros. This is not my concept. Okay, now I would like to moving on to the major one, reshape. This is the function. So reshape function is there. So what is the use of a reshape? Why we are using a reshape? Okay, so you know that the multiplication of vector. Say for example, I have a vector. When we are dealing vector, mostly vectors are column vectors. So I have a vector like 1, 2, 3, vector 1. Okay, so and I have a vector, another vector, vector 2, which is having values like 4, 5, 6. Okay, now I would like to do vector 1 dot product. That means multiplication of vector 2. Okay, so I would like to multiply these two vectors. How we are multiplying? In mathematics, we'll multiply directly like 1 into 4. Okay, because a matrix multiplication 1 into 4 plus first row, first column. 1 into 4 plus 1 into 5 plus 1 into 6. That creates first row. The second row with second column. second row with first column and second column like this. Okay, so when we are doing such kind of multiplications in matrix, it is not applicable when the columns of first matrix dimension is not equal to the column row matrix. Okay, so if these two are equal, column value of first matrix and row value of second matrix, if these two are equal, then only we'll do the multiplication. Otherwise, the multiplication is not possible. So this is 3 by 1. Okay, this is also 3 by 1. Okay, so first matrix column value is 1, second matrix column value is 3. So these two are not equal. So matrix multiplication is not possible. Correct? As per the basic mathematical matrix multiplication, the multiplication will be done. So whenever it satisfies this condition. Okay. So here, when we are having two column vectors, multiplication is not possible. When we are having two column vectors like this is 2 by 1, and another vector, this is also 2 by 1. So this is 1, this is 2. 1, 2, not equal. So multiplication is not possible. In this case, in this type of situation, we are going to use one vector should be a row vector and one vector should be a column vector. Then we can do the multiplication. So this is first element, second element, third element. That means one row with 3 columns. This is one column, first one, second one, third one. So 3 rows with 1 column. Here we have 3 columns, 3 columns. Here we have only 1 column, 1 column. Here it is having 1 row. This is 1 row. Here it is having 3 rows, 3 rows. So first matrix column is 3. Second matrix row is 3. These two are equal. So then multiplication is possible. So how we are going to convert our vector into row vector? Okay. So for that we are using reshape. Okay. This is the intensity of my theoretical derivation. Okay. So reshape is used in our Python programming. We are using a reshape function to change their shape. Okay. So what is this np dot zeros of 3? np dot zeros of 3, it creates a row vector with 3 zeros. When I use np dot 3 dot reshape of 3 minus 1, that means we are going to convert this into a column vector, transpose. Okay, reshape is nothing but a changing of shape. Okay, so earlier it is 3 by 1. Now we are reshaping into 1 by 3. Reshaping is, so for that we are using reshape. You should remember I am not using much more functions. So only simple function, array function. Okay, so I am using only simple function, array function, and I am used only zero function, zeros to represent the zeros. One, if you want to represent 1, you can use 1 function. Okay, once function is there. Then I am using reshape function. At least you could remember these 3 functions because we are doing calculations and vector. That means you should remember these 3 things. Array function, zeros, it is not required zeros. We can give our own values. Your remembering function should be like a reshape function. Okay. These 2 functions, array function and reshape function. You just remember these two. Now comes into the another example. As of now, we have created vectors only, row wise, column wise. In this example, it is representing to create a matrix. How we are creating matrix? In our programming called Python, the matrix are created with two-dimension array. As per the definition, vector is one-dimensional array, matrix is two-dimensional array. So here we are we should know the thing array, one-dimensional array, two-dimensional array. So array is a function we are using to represent vector as well as matrix. So this is matrix example. Even though it is matrix example, we are using array function np.array mathematical library function np.array because it is array. Okay, in this array, you know that how we are representing this array elements. So this is one row, this is another row, this is another row. So three rows. So with this, it creates three rows. First row, second row, third row. And how many columns? This row is having first column, second column, two columns. First column, second column. Second row is also having two columns. Third row is also having two columns. So my matrix is three rows, two columns. 3 by 2 matrix. So it creates 3 by 2 matrix. So these are all 2 minus 2. These are all the values. 2 minus 2. 3, 1, 1, 4. These are the values. Okay. It creates 3 by 2 matrix. Like this, we are creating a matrix. Okay. Now, transpose. Like reshape function is used for the vectors, changing the shape of the vector, row vector to column vector to row vector, which is nothing but a transpose. Okay, so but in mathematical concepts like array, we have a transpose function. So using transpose function, we can convert row matrix rows into the columns into the rows. Okay, we can convert 2 by 3 matrix instead of 3 by 2 using transpose function. Okay, so this extra another function you need to remember, transpose function. Okay, that is applied in matrix. The same thing is performed in vector using a reshape function. So if you want to perform the calculations on vector and matrix, you should remember how to create array using array method, array function you should remember. And sometimes it is required to convert rows into the column. The vector point of view, you should remember reshape. The matrix point of view, rows, columns, conversion, you need to use transpose function. These three functions you should remember. Okay, in matrix, we are doing several operations. Okay. In the last class, we studied like so many operations are performing in a matrix. Transpose of a matrix is one of the major operation, right? This is the function to perform that transpose operation. Like that, we have addition, we have multiplication. So we will do addition, multiplication, and other things. Okay. Another operation, another type of a matrix is identity matrix. So how we are defining identity matrix? We have a function in Python. Okay, so we have a function in Python, identity. Okay, so identity function which creates identity matrix I. The identity of 2 means it creates 2 by 2 matrix. Identity matrix is always square matrix. Okay, so it creates identity matrix two dimensions. So that means main diagonal, you just remember main diagonal values are 2 main diagonals. It is having 2 values. So like this, we are using the functions transpose function, identity function, okay, some other functions. So now these are the examples, basic examples, how to convert or how to create vectors and matrix. And also you have learned graph, how to convert graph into matrix. Okay. So now our next concept is like a linear dependence and span. Before starting this linear dependence and span, I would like to run this program. For more understanding purpose, I'm running this program. You just see. Okay. I'm going to open Python ideally. I'm going to take new file. Okay. I'm considering so I'm importing because of time I'm copying, otherwise I can type. Okay. So I'm copying here content. See this content. I'm creating a column vector. This is the thing I already explained. You just run this one. Save this file like DL1 example. No, this is vector. Vector 1. Would like to store this vector. Module numpy import numpy as np. Numpy is not there. So module not found. We need to install numpy using pip install numpy. That should be done in command line, I think. Okay, we should install that. Installation takes time. Instead of that, I would like to use. I would like to use. I'd like to use. Better use Colab. Colab. Google Colab. New notebook. Colab notebook. To use this Colab notebook, you need to have internet connection. Okay. When you have internet connection, you can do this. Otherwise, it is not possible. Okay. So now I'm using this code in my Colab. So now I'm having this. See here, it is created a column vector. Okay, so I have displayed this statement using printf column vector and vector name. It is displayed vector name. Okay, so first element is 4, second element is 3. So first row having first element, second row having second element. If you want to remove these, you can remove. So this gives error because it is not proper declaration. It indicating 2 rows with 1 column is not possible. 2 rows, 1 column, this is not possible. So you have to represent like this. Sir, 2 rows, 1 column is also possible, sir. Yes, I will show you later. I will show you that is there. Okay. So this is the way you need to represent. And one more thing you should remember, shape of the vector. What is the shape of the vector? 2 by 1. That means 2 rows in 1 column. 2 rows, 1 column. This is uh, uh, shape 2 by 1. Okay, what is the shape? Shape of the vector 2 by 1. That is matrix representation 2 by 1. 2 rows in one column. Now, similarly, I would like to create, I would like to convert this vector into the row vector. Okay. Row vector. Just use reshape. Okay. You just use reshape. NP dot reshape of a vector. So it is nothing. Nothing is there. It is simply like reshape. NP dot reshape. You have to mention dimensions. Otherwise, it gives error. It could be like name of the column, and then you need to replace that. Okay, that is the thing you need to do. Converting that into the rows into the columns. But our target is we are doing calculations on this one, transpose. So you should remember how you are representing transpose. That is measure 1. So I'm using this. Copy. The normal just creation. I'm displaying this using, see, this is displays our matrix 3 by 2, 3 rows and 2 columns matrix. Okay, and the measure one is identity matrix np dot identity matrix. Okay, np dot identity matrix I is equal to np dot identity matrix of display type. This is identity matrix 1 0 0 1. Here it consider 1 point something, 0 point something. Okay, point also represents. So when I write like this is 4, identity matrix 4. So then it creates 4 by 4. So always it creates square matrix because identity matrix is a square matrix. Okay, so like this we are using all our basic operations which we learn here. So you need to do the programming. The thing is, finally, you should know how we are representing all matrix values, vector values, and scalar values. This is our main target. Transpose identity. Now, comes into the linear dependence and span. So linear dependence, that means our elements are algebra, linear algebra, our elements are, variables are depends on other. Okay. Here in this example, ax equal to b. Here, b value is depends on a. Okay, so how we are deriving this value means b is dependent variable, b is dependent variable, and here a x is a independent way. Okay, sometimes we are writing like y is equal to slope of a this mx plus c to find this slope. Okay, so this y value is always depends on this x value. Here c is a constant, m is a parameter. Okay, so that is we are representing to find this independent value x. Okay, so we are simply moving this value from left side to right side, that is b by a. Okay, so x equal to b by a. We can write like a inverse of b. Okay, so a inverse of b. So this is the usage where we are using inverse. Okay, so how you are converting this matrix A matrix into inverse matrix, you know that. Okay, so why I am saying A is a matrix. Okay, so my intensity is I'm not dealing mathematics. Okay, you know all these fundamental concepts. My job is I would like to give you information how we are representing these things. Okay, here B is a lowercase letter. This is a vector individual. Okay, so x is a lowercase letter. This is also a vector. Okay, vector or a scalar. Okay, here a is a capital letter. That is, it is a general definition. Matrix is represented with uppercase letters. So this is a matrix. That's why I'm saying inverse of a matrix. So now you know that we have a matrix A, and you know how to do the inverse of a matrix inverse, and then you can do the multiplication of this vector value with the matrix. So this type of calculations we did earlier in our last class. Okay, in order for A transpose is exist, must have exactly one solution for every value of B. So for every value of B, it is having exactly one solution. This is exactly one solution. So one dependent thing. However, it is possible to the system equation to have no solutions or infinitely many solutions for the same variable B. Sometimes it is possible it is having no solutions, zero solutions, and also sometimes it is having infinitely many solutions. Okay, so this is also the okay, so that we can how we are representing these dependencies matrix in terms of a span. Okay, span means existence. How much the values dependent values variables are exist in our space. Okay, so say for example I have a matrix AX. So here A is a matrix and x is a vector. We are doing multiplication of these. Okay, so AX, that means A1 x1 plus A2 x2 plus first row, right? A1 x1, A1 second column, A12 x2, okay, AI J xn, like this, second row. Similarly, third. So this is a final matrix AX. Okay, so like this we are doing. How it is connected means this A is a column vector, this A is a column vector, and this A is a column vector. That is matrix. Okay, array variable, and X is a individual value because I mentioned that in earlier here I mentioned that this is a vector, this is a vector, this is a matrix. So sorry, this is a scalar, this is a scalar, this is a matrix. Scalar is individual element. Okay, now here we have a scalar x1, this is a scalar x2, this is a scalar. Yeah, say for example x1 equal to 1, x2 equal to 2, x3 equal to 3, x3 equal to 3. Okay, like this we have a scalar values. scalar values, and we have a matrix. This matrix may be a row matrix or a column matrix. Okay, so this will be represented a1 into x1 plus a11 into x2 plus a1n into xn. So all these together it forms first term. Okay, so when we are multiplying scalar with array, that is a matrix or a vector, it creates a vector or a matrix. Okay, so when we are multiplying scalar with scalar, it generates output as a scalar. So because 1 into 2, 2. So similarly, when we multiply vector with vector, it generates scalar. You just remember this is, so when we are multiplying vector with vector, it generates scalar. Okay, so when we are multiplying scalar with vector, okay, scalar with vector, it generates a vector. Okay, when we are multiplying scalar with matrix, it creates matrix. Okay, you should remember these things are fundamental things. Okay, so scalar and scalar, it generates scalar. You know that it is a general common. Vector and vector multiplication, it generates scalar. So matrix and matrix multiplication, it generates matrix. Okay, so matrix and scalar, matrix and scalar, it generates a matrix. Vector and scalar, it generates vector. Like this, it will be converted. So that conversions we are applying here. Okay. So here it is. What is this? This is a vector. So this is a vector, this is a vector, this is a vector. So this is a scalar. Scalar and vector multiplication, okay, which generates a scalar. So what is this scalar? A11 x1. This is a scalar output. Second one, what is the scalar? A21 multiplied with x1. This is second element. So, and so on. am1 x1. So this is first scalar and vector multiplication. Similarly, second scalar vector multiplication, it creates this vector. Okay, and so on. Nth scalar and vector, it generates a vector. So vector and scalar multiplication, it generates 3 vectors. So okay, so here we are doing addition operation, right? Adding of a vector. So addition of a vector, so vector plus vector, it generates a vector. Okay. So matrix addition, matrix plus matrix, matrix. Scalar plus vector, vector. Okay, you should remember. So by adding all these things, we'll get AX. So how we are calculating AX? When we have a slope value, scalar value, as well as a vector value, you need to perform this type of calculations. These things are very, very common things we are doing in deep learning programming. Okay, image processing. Suppose when we are doing any image processing, classification, as I mentioned in first class, based on the image input, we need to find a particular output of the image. So there we are using scalar, features. Feature values are multiplied, feature vector, we can consider feature vector. Color, say for example, that image we discussed in the class, based on hair, based on color, based on nose, based on eyes. Okay, so these are all the features. Eyes are features, nose are features, and so on. So like we need to create a vector. Okay, I'll tell you a simple example. We need to create a vector for nose. Okay, so we are creating vector for nose. nose of the first dog, nose of the second dog, the third dog, fourth dog, fifth dog, and so on. So that we need to we need to store all nose information, all nose image nose information. Say for example, I have 10 images, 10 dog images. I would like to store all 10 dog nose images, nose data into the vector. So similarly, we can create a matrix which is having two features, nose and color, eyes and nose. Like we need to extract the features, then we'll do the operations. So this is the reason why we are creating vectors and matrix, and why we are doing the calculations like multiplication, addition, and all. You should remember these are all fundamentals only. These things we are using. So that means this mathematics is not required. Programming is required, like np.transpose, np.array. Those things are required. This is for understanding. This mathematical calculations for understanding the concept. I think it is clear, right? Then comes into the norms. So norms are very, very important things. Okay, what is this norm? Norm is nothing but which defines some standard rule. Okay, norm is nothing but which defines some standard rule. What is this norm? See here, the span of a vector is set of all points obtainable by a linear combination of the original vector. Okay, so span of a vector. What is the span of a vector? That means space of a vector. Okay, so this vector space is created so based on set of all obtainable, okay, all possible linear combination of a vector. You have seen like x1 a11 x1 plus a12 x2 plus and so on an1 xn. Okay, so like this we are creating all possible combinations, okay, that will be placed in a vector. So then determining whether ax equal to b has a solution or not, it is having any particular solution or not in that particular space here in this particular span. Okay, in this particular span, is there any solution is exist for this example x equal to b? That defines a norm, that defines a rule. Okay, these are all theoretical things, it's not required. The main thing here it is, so how we are representing these norms. So in mathematical, a norm is represented like this. Okay, but in programming we are using norm function to find the norm of the vector. That is, if we want to measure the size of the vector, we are using norm function. Norm is a rule which defines span. Okay, span of the vector. That means possible outcome of this space, vector space. So all together, it's which defines the size of the vector. Okay, so usually we are representing L to the power P now. Okay, so these values always should be a non-negative, because norm values are non-negative. It is having modulo. Okay, it is having modulo. It doesn't have any negative values. Norm values are always positive values. Okay. Now see here, the magnitude of a vector. What is the magnitude of a vector? Magnitude is nothing but a distance. Okay, that is distance of a vector. Or else size of the vector simply. The vector 3 by 3, that is what is the magnitude distance of the vector 3 by 3? This will be calculated like a norm of a vector. Okay, so magnitude of a vector 3 by 3 is nothing but calculating the norm of a vector. So how we are calculating this norm of a vector is square root of v1 square plus v2 square plus and so on vn square. That is distance calculation. Okay, so using this, we are calculating a norm of a vector 3 by 3. So this is, we have v1, v2. Okay, vector 1, vector 3 square plus 3 square, that is 3 square is 9, 3 square is 9, square root of 18, that is 9, square root of 18. Okay, like that we are defining the norms. This is very simple thing defining a norm. Important one is eigen decomposition. I will continue eigen decomposition definition and how we are using eigen decomposition. What is the importance of decomposition? That means dividing our task into multiple tasks. Okay, so this is breaking them into the small parts. Okay, equal parts. That is eigen decomposition that I will discuss in the next class tomorrow. Sorry, Monday. I'll tell you, we are having classes on Monday first hour, Tuesday first hour, Saturday 9:40 to 10, 11:10 or 11:20 something. Okay. This is about our today's class. Now comes into the conclusion. What we learned today? Today we learn the programming part of our scalars, vectors, matrix, and its operations. Operations are performed on types of a matrix, types of a vector. That is row vector, column vector, and types of a matrix, one-dimensional, two-dimensional, transpose, inverse matrix. And one more matrix type is there. I forgot to explain. That is symmetric matrix. Okay, you know identity matrix, you know transpose matrix, you know orthogonal matrix, diagonal matrix. Okay, now we have one more matrix type, that is symmetric matrix. What is this symmetric matrix? Symmetric matrix is nothing but a similar, same matrix. Okay, so what is the same matrix? The matrix A, which multiplies with the inverse of the matrix or transpose of the matrix, also generates same matrix A. This is called symmetric. Similarly, we can write A transpose into A. This generates same matrix A, self matrix. Okay, so when the matrix satisfies this condition, then we can say that matrix is a similar, same matrix, symmetric matrix. Okay, so that means A and A transpose equal to A transpose and A equal to A. So this, when this satisfies this condition, then we can say that is a symmetric matrix. Like you have several matrices, rank matrix, delt matrix, okay, determinant matrix. So many matrices are there in mathematics, but all those kind of matrices are not using in our programming. Based on the importance and based on the calculation, we are using frequently this kind of matrix: normal matrix, transpose matrix, symmetric matrix, orthogonal matrix, diagonals we are picking. Okay, diagonal matrix, upper triangular matrix, and lower triangular matrix. Only these things we are using. Okay, so you know how to do the transposition, how to do the multiplication, how to do the inverse. Now I would like to tell you how we are getting this diagonal using DIAZ function. Okay, in programming np.dia. DIAZ diagonal diag function, it gets diagonals. Okay, so similarly, upper triangle. Upper triangle means diagonal matrix. Okay, so the elements below this diagonal should be 0. So then we can say this matrix is upper triangular matrix. Okay, so how we are representing this is TRI triangle U. TRI of U. TRI U triangle upper. Okay, upper of A. So then it generates upper triangular matrix. Say for example, I have values like 1, 2, 3, 0, 4, 5, 0, 0, 6. Okay. When we have a matrix like this, then you can retrieve upper triangle. This is upper triangle. Okay. So this is upper triangle and this is diagonal and this is lower triangle. So upper triangle, we are writing TRIU, it writes value like 2, 3, 6 because these are the elements are forming a triangle, upper triangle of the diagonal. So similarly, lower triangle TRIL, TRIL of A. So that means diagonal downside, lower side having values, upper side having zeros. So like this, we'll use, this is also used in our programming. That's why I'm explaining now. So how many functions you should remember? Defining array, np.array function, transpose, np.transpose function. Okay. Similarly, reshape for the vectors, np.reshape, third one, and inverse and lower triangle, upper triangle, diagonal. Okay. These are the functions frequently we are using in programming. So those you should remember. These are things we learned today's class. In the next class, we'll see how we are doing decomposition and importance of decomposition. So this is from my side. If you have any, if you want to ask any questions, you can raise your questions.